Hi, welcome to Mathematics with Tom. This is Tom, and today what we're going to do is we're going to prove a simple case for L'Hopital's rule. And L'Hopital's rule says this. It says let f of x and g of x be differentiable functions such that f of a is 0, which is also equal to g of a, and that the derivative of g at a is not 0. So what we have to do is we have to show that the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. So what we're going to do in our proof here is we're going to do this, and we're going to start on the right hand side. So we're going to begin on the right hand side, and then we're going to work through our proof, and when we're done we'll end over here, end on the left hand side. So that's what we're going to do. And before we do that, I want to do this. I want to do a little let's just do a little reminder, and that is this. Remember this. So remember another way to write the derivative. And I'll show you how that works. Derivative. So normally we would write that the derivative is the limit as h approaches 0 of f of x plus h minus f of x, divide that by h. And you may have forgotten that really there's something more in that, and that was this, and that was that this really came from x plus h minus x. Those all just cleaned up. And so I could really write, and I should go back, let me redo this. This is my f prime of x, but this is also, so we can rewrite this now as, so in other words, as h approaches 0, but really what we have is we also have, in other words, the entire denominator goes to 0. So I'm going to write this as the limit of x plus, in big parentheses, x plus h minus x, because that's all still just an h. All of that goes to 0 of f of x plus h minus f of x over x plus h minus x. So what we do is, you can think of it this way, as let's do a little substitution. We're going to let x plus h, we're just going to call that x, and we're going to let x be called a. And so really what's happening is this. Is normally when we would take a derivative, we would start here at the point x, and then we would move over a little bit, and this distance here would be h, and so this point would be x plus h. And so then what we would do is our limit, and I shouldn't put the arrow, so h was that, but our limit was this. Our limit was to move x plus h back. And so another way to write this is we're just going to call x plus h our x, and the point at which we're looking at, we're going to just call this a. And so if you use that, another way of writing the derivative is f prime of x is equal to f of x minus, that's this point here, which is the same as the x plus h, minus f of a over x minus a. All right, and that's the form we're going to use to prove L'Hopital's rule. And here we go. Let's try that. So if I write this as L'Hopital's rule, here's our proof. We'll go back to our gray. So our limit as x approaches a of f prime of x over g prime of x. Well, remember that the derivative of f prime of x, this is really the limit as x approaches a. Oh, and I forgot it right up above. Goodness gracious. Right in here, I should have had the limit as x goes to a. Okay. And then, so the limit as x goes to a of f of x minus f of a over x minus a on all of that is over the limit as x approaches a of g of x minus g of a over x minus a. And now here's the neat part. If you recall, this you have to divide fractions. And so when we do this, I'm going to when move the limit back out, we have the limit as x approaches a of the top fraction, that's f of x, f of x minus f of a. All of that is divided by x minus a times, then we flip and multiply. So the reciprocal of the denominator, that's x minus a over g of x minus g of a. And now look at what we've got. We've got the numerator and the denominators. These are common factors, so I can cancel those. So I do that. And let's move up a little bit. We're going to use our screen here. We've got the space. So write this as the limit as x approaches a of f of x minus f of a over g of x minus g of a. And now a couple of things here. Notice is that I should have come back and I should have noted that, remember that we said that g prime of x is not 0. So evaluated a is not 0. So this would be, my initial assumption is you always have to use your pieces. This is okay because the limit as x approaches a of g prime of x is not 0. So we can have, that's okay. And then that was our opening assumption. That was highlighted. That was this assumption. Now we have to use our other assumption, and that's this. That's that our other assumption here is, that f of a and g of a are both 0, because that was their original problem. Well, if these are both 0, that's these pieces right here. Those are both zeros. And so I can say that this is the limit as x approaches a of f of x over g of x. And if you look back, that is what we were trying to prove right there. And that is the simplest case for L'Hopital's rule. The other proofs get more difficult, but I thought you'd like to see one. I hope you enjoyed that, and we'll see you in the next video. Thanks for watching.